All right, everyone, it's 11:30. Welcome aboard. Go ahead and make sure your mics are unmuted, make sure your cameras are on, and we will get started. Several of y'all are in the looks like in the participants right now. I'm not seeing any cameras or mics. I don't know if y'all's aren't working or if it's on my end. I might be stupid, but y'all just go ahead and get all that set up and we will get going. And go ahead and let me know if you can hear me as well, because I can't hear any of y'all. Okay, so Adam, you can hear. Okay, so I don't know about anybody else though. So if you can hear me, let me know. But also, I can't see or hear any of y'all, so I'm not sure what's going on there. Looks like I got 7 participants so far. Waiting for some more to hop in. We will get going. See, Sander, hello,
Hi, Toby.
hello. Sander, what is your first language from where you are?
Dutch.
Dutch. Okay, I speak a little bit of Dutch, but not very much. I speak more German than I do Dutch, but
That's all
um,
right. I speak German as well, or a bit Spanish.
yeah, meine Deutsch is nicht so good. But yeah. Okay, very good. So I'm waiting for some more people to hop on. I see a bunch of people's names, but I don't see any faces or I can't hear anybody. So if you guys can hear me, go ahead and make sure everything's turned on your end so that we can make this interactive and not just a lecture from Toby because I lecture enough people. I don't want to have to lecture you guys. So if you could just hop on, that'd be great. All right. Looking at the list of questions that we had from last time. Let's see what's going on. I just uploaded this morning both of the calls from last time, the call from 18 and 19 of March. So those are all in the classroom on the mastermind, and they're both over an hour long videos, so very helpful. So we'll go ahead and do that. As far as the list of questions that I had from the mastermind, where was it? Here it is. I was asked about the differences between analog and digital instruments, as well as how to read analogs, about bearing pointers as well. Those are the ones that we've got listed there to talk about. But in the meantime, we'll go ahead and start with whoever has some questions. We can go ahead and start first. Pico, welcome. How are you? Okay, your mic doesn't work. Is that right? Okay, I'll go ahead and I'll go ahead. Yeah, I cannot hear you, but you can hear me. So I'm going to go ahead and just mute your microphone on this end, even though it doesn't work anyway. So if you have any questions, you'll have to post them in the chat. So there is that. All right, I see 8 of y'all in there. Go ahead and make sure we got a good sound check. So Marco, can you hear me? Jose, can you hear me? How about Emily? Emily, can you hear me?
Yeah, I hear you.
Okay, wonderful. All right, awesome. Well, we'll go ahead and get started then and go from there. All right, questions. Let's go ahead and drop them down. Xander, what you got?
I don't have any questions for today. Last night was very helpful.
Okay, very good. That's what we want to hear right there. Perfect. All right. Emily, do you have any questions?
As of right now, I don't.
Okay, cool. Does anybody have any general problem areas with their training or anything related to instrument flying. And it doesn't have to be, I mean, I'd like it to be strictly instrument flying because that's the purpose of this call. But if everybody is feeling good about their instruments today because the last calls were just so helpful, then we can also talk about aerodynamics or something as well, or instructing. But I prefer to keep it on instruments. Does anybody have any areas? And don't be shy. We're all learning how to do all this stuff. And even if I'm one teaching, I'm still learning every day about how to make this even better and better. So don't be shy. Go ahead and let me know what exactly is going on.
Yeah.
Adam, good to see you.
Hey, how's it going? I got a little problem area, I guess. It's
Sweet. Well,
it's
that's
really, I
unfortunate, but we're going
guess,
to help you fix it.
yeah, it's probably more or less just cockpit management, but I find um I'm getting better now that I've gotten better communicating on the mics and everything, and just really knowing what the pertinent information is when listening for air traffic control. Like, you obviously know you're going to do, if you're on ILS, you're on ILS, so you don't need to necessarily worry about remembering when they say cleared for ILS. It's just the runways you really got to remember, and what the altitude heights they want you at. And I'm getting better, but I still get fumbled up and get little task saturated, coming up on my final approach fix and really making sure I'm like at approach speed 90 flaps 10 within a half mile of that final approach fix. And I tend to sometimes, when I'm looking at my minimums, and sometimes I have this tendency where I like, man, I just kind of, my fucking hand, dude, excuse my language, I always lean one way, or I just, when I'm briefing, so just being able to be more focused when I'm approaching the final approach fix and not be so anxious, and just to be able to stay ahead of the plane, because I am ahead of the plane, but it's just, I don't know, it's just when I get there, it just seems like a lot of stuff's hitting the fan.
Sure.
And every day it's getting better, but it's just, I guess, it's still like, I guess what I'm wondering is what in your brain, what is your process when you're coming in vectoring to your, and they say, vector to 3-3 heading and intercept the localizer. Where's your mind going from there?
Sure. That's a great question. And thank you for being so vulnerable with your problem. That's very good. This is actually a problem that probably everybody in this chat has had experience with at some point, if not continuing to experience that. I have a couple questions for you to kind of dig a little more before I can give you a really solid answer. I have some answers, but I'd like to kind of dig into some stuff here. Where do you typically, how do you hold the flight controls? Or first of all, are you using a yoke or a stick?
First of all, I am looking at you. I just have a bigger screen to the left, so I am looking at you.
Okay, that's fine.
But I'm Cessna 172.
Okay, so you have a yoke.
Use this
and
with my left hand, I'm in the left seat, and right hand on the throttle.
Okay, it's like this. Okay.
Yeah.
Do you typically use fingers or do you typically use a grip?
I've been using a grip, and I've been noticing my hands kind of on the lower half of the horn, which kind of makes me push up a little bit and want to drift to the right. So I've been trying to loosen my grip and come up to the side a little bit, and that seems to be helping, but I'm always
And
open.
how much total flight experience do you have in that airplane?
I'm at 160 hours
Total time or just in that airplane?
total time. Or
Okay, cool.
well, I've been flying one, so what we fly 172s, K, B, and I models.
I have a B model 172. It's an old
Nice.
airplane.
Yeah,
I
love the
love it.
mechanical flaps.
Oh, dude, it's so nice. I was
Yeah.
demonstrating a short field to somebody the other day, and I said, hey, I bet you I can put the left wheel on the 3.5 on the runway. So I put the left wheel right on the 3, dumped
Nice.
I had it stopped in like 300 feet. It was crazy.
That's sweet. Yeah.
And they were
Those
like, "How'd you
Continentals are
do
so
that?"
nice
And
too.
they were like, "How'd you do that?" And I was like, well, whatever, no big deal, it's just another day. Um, but anyway, there's something called proprioceptive feedback. I'm going to share my iPad screen. I figured out how to connect my iPad to the how do I do this? It was just working earlier. I figured out how to connect my iPad to the computer, so my iPad can actually display to the computer, and then I can share my computer screen from the iPad. So it's very cool, but I have to set it up because I just disconnected the plug and have to reset it up. So 2 seconds and I will show my iPad screen. Okay, perfect. It's working. So now I shall go here. And if any of you guys are instructors and ever want to know some of the tricks that I use for how to teach these Zoom lessons with iPads and drawings and everything, I can show you later on some of the tricks that I've used to make that work. So In the meantime, here is this. With me. That should work. How do I make this part go away? Maybe. Let's see. Okay, a little box. I'll have to figure that out. But in the meantime, we'll just continue. How in the world? Let me reset that real quick. But I do have some points. I wrote these points down as you were talking. We're going to talk about cockpit management. We'll talk about PTAC, leaning, and then proprioceptive. We'll start with proprioceptive because it's a physiological and neurological connection between what you're doing, what you're thinking about doing, and what you feel. Occupational therapists. So, for example, whenever you you break a leg or you have to have a knee replacement or something, you go to a therapist, right? And the therapist can, move your limbs around and help you get the connection between what your eyes see your hand doing versus what your hand feels. And it takes that connection between what you see, what you want to do, and it takes the sensations and moves it all the way through your hand, down your arm, up into your shoulder, then up into your brain, right? So we can actually use these to help have a better feel for the airplane and not do things unintentionally. But I will show this to you if I can get this to work. So give me a moment to play with this for just one moment. I had to restart QuickTime. New movie recording. Go back to here. Okay. I believe that will work. And now I will share the screen. Fantastic. Thank you for your patience. And here we are. Maybe. Yes. Okay. So proprioceptive. Proprioceptive is the concept of when your hands are feeling something. You have the connection between I see my finger rolling this pen and I feel it happening at the same time. So if anybody in the chat can do this too, let me know in the chat if you've experienced this. Just have a thumbs up or something. Have you ever been flying along and you have been holding the yoke or something, and then you're flying, let's say it's in turbulence or something, and you try to take your hand off the yoke, maybe you have two hands on the yoke, you take one hand off the yoke to go push a button on the radio or touch your iPad, and the turbulence bumps your hand around, and you're floating the whole time, and you try to hit the screen or the button or turn the knob, and every time you move your hand forward, you feel your hand moving forward to touch that knob, but then turbulence knocks it out of the way. So the feeling between what your hand feels it doing versus what you see it doing are two different things, and it causes confusion. Has anybody ever been through any kind of spatial disorientation through that, right? It can be very disturbing. You're kind of like, oh man, your head's swimming. You feel like you're bouncing around the whole time. You can't really get anything done. You feel like, how am I ever going to control this airplane, right? Raise your hand if that's happened, right? Happens to me all the time. Well, it used to happen all the time. Now I kind of figured out how to make it not happen. But if you haven't experienced it, you actually probably have. It's just I'm explaining it poorly. So I'm sorry. But whenever you're in turbulence and you're trying to deal with it, for example, how many of you fly touchscreen MFD, PFDs, or GPSs? How many of y'all fly touchscreens? So we got 1, 2, 3. I only see a couple cameras. Emily's got one. Okay, cool. So several of you guys are flying touchscreens. Have you noticed how your instructor will tell you to put your hand up against the side? Let's say my phone here is my touchscreen. They'll say, put it up against the side of the device, and then use your thumb kind of like this to then move things around. And that way your hand's stable, right? Because your hand is stabilized. If you see my screen on the side here, your hand is stabilized by the side of the device, right? You can move it around and touch things. This is an example of using proprioceptive feedback to get a more accurate input for what your body's doing versus what you see and what the turbulence is telling you to do. So for example, if I did not do that and the phone screen was bouncing around the whole time In fact, I'll stop the screen share for a moment. You can see me, the phone screen's bouncing around the whole time, right? If I'm trying to go reach for the button, I hit the button and I hit the wrong app and it's like crazy. I can't exactly get to it, right? Because it's bouncing around. But if I grab it on the side, now my hand is moving with the turbulence of the screen of the GPS, and I'm able to use my thumb more accurately to select exactly the application that I want. So it seems very simple, which it is. It is very simple. The trick is, it's so simple we forget to do stupid stuff like this, just to put your hand on whatever it is you're using. Now, this has to do with the yoke. This has to do with you turning and whatever. I tell people when they are flying with me, I say, do not float your hands. Do not float your hands. I want your hands to be either on something or on nothing, like just your lap or something. You know, if this is the yoke, I want you to have a hand on the yoke. I don't want you to be death gripping it and squeezing it to death. I don't want you to do that. I just, I want it at least resting on the yoke, or not at all. Maybe 2 fingers. That's fine as well. Just 2 fingers on the yoke is okay. But you don't want to be just floating around the yoke, because you know how you may have an autopilot. Do you have an autopilot, Adam? You're muted.
No, we don't have any autopilot.
Okay, so let's say you did have an autopilot, right? But you've had times you use your trim wheel set real nicely, and you can kind of let go for a minute. No, you have an autopilot, and a lot of times you'll have your hand just kind of floating by the yoke, saying, "Oh well, I can just touch it every now and then if I need to." A little poke here, a little poke there, and the airplane smoothly goes where you want it to go. That's fine, but if you have an autopilot, a lot of times they'll just float. So I tell people, I want your hand completely off the yoke when the autopilot is on, or on it, but not doing anything. Don't float, because if you float your hands, when turbulence hits you, it causes your hands to go places where your brain does not think it is. It's like your brain says, oh, my hand is right here, but your eyeballs say, oh, my hand is over here. Which one's correct? Well, obviously, you know with your eyes that your hand is over here. You know something is wrong. But because your brain picks up something is wrong, it starts getting a pump of adrenaline into your system. Because think about it. Adrenaline is the chemical that's in your brain that comes out for like fight or flight, right? We got to do something. We're preparing for battle. You know what I mean? It's what your body is preparing for. It's, the whole inner core human nature. So when it's disconnected, that happens, and it causes adrenaline. And guess what adrenaline does? It slows your brain process down. And as your brain process gets slowed down, it's like you can't function correctly. It's like, what was I just doing? What was that frequency again? And you're like, you don't know what you were doing. You're fumbling through the airplane. I've seen this happen thousands of times in the airplane with other pilots and students, and it's happened to me as well. So I tell people, don't float your hands. Now, if you guys want to go try this next time you fly, I suggest having your instructor take the airplane, and you ask the instructor to take control of the plane and to do some maneuvers, like move the yoke back and forth. Don't do this very quickly. You don't want to exceed the structural limits of the airplane, but go up a little bit, like a little bump, and then a little down, kind of like a little zigzag, and then maybe put some rudder and some ailerons into it. Make it to where you're kind of in the airplane doing this very lightly, nothing too crazy, and then try to move things in the airplane and touch things very specifically. Say, grab the radio knob and twist it this many degrees, or touch the CDI and do this. You'll find it is very difficult if your hands are floating around trying to reach and grab for things. Like, my chair is sliding around back here, right? It's very difficult. But it's much easier if while the chair is sliding around, you grab onto something. Grab onto the GPS, or, if you have your iPad, grab onto the iPad, put your hands on it, stabilize yourself somehow, and then, use your thumb to change whatever it is you're trying to change. If you do that, you'll notice that you have an immediate sense of control with what you're doing. So this immediate sense of control is called proprioceptive feedback. You know how we're always taught that growing up we have 5 senses, right? Sight, taste, touch, whatever, right? There's actually like 14 senses, and proprioceptive is one of them. So this is a very common thing. So the whole reason I'm telling you that is there is a science behind what you see and what you feel and the connection between it. So rule number 1 is don't float your hands. Rule number 2 is grab onto something and stabilize yourself. That's that. Now, how does this apply to you using the yoke correctly? If your hand is too tightly gripped on a yoke, you're not going to be able to feel what the plane's doing as well. And it tends to take the weight of your hand and pulls down on the side. So that's why I say just grab a couple fingers on the yoke. That way there's not as much weight trying to pull you down. Additionally, improving your scan will help with this. Whenever you go to change a radio frequency or something, look at the radio, put your hand on it, and back at your instruments, make sure your attitude's good, then change some things and back to your attitude and then change some things and so on. I find people tend to take too much time looking at their heading indicator and their altimeter, when really the attitude indicator is the #1 instrument that will tell you if the airplane is changing its trajectory. In fact, I encourage you guys sometime to go with your instructor, take some sticky notes and stick them over every instrument in the airplane except the attitude indicator. Try this and ask your instructor or to give you to I don't know to know what altitude you started at and what heading you started at. So I started on a 3-6. Start on a 3. Sorry, I'll almost done. Start on a 360 heading at 3,000 feet or something. Then cover up everything, and then fly in that perfectly straight line for 5 minutes. Only looking at the attitude indicator, and do other instructions like change your radio frequencies, adjust the GPS, change the airplane configuration or something, right? And see after 5 minutes how close you are to your original heading and your original altitude. And you'll find you'll be within, less than 100 feet. If you do it correctly, it'll be less than 100 feet and less than 10 or 20 degrees. So it's very accurate. So go back from your scan over here, managing your cockpit, back to the attitude indicator and keep that your scan. Now, of course, don't neglect all the other instruments in the real world, but for the immediate scan, I need to know this information right now, it's the attitude indicator. Does that kind of click a bell for you?
Yeah, yeah. Another issue too to kind of compound this, with these older planes, some of the DG's procession is pretty terrible, to be honest. And when you're on final approach fix, getting right there, you're kind of a little nose down. Your compass kind of, these compasses in these old planes, the ones I'm flying, are kind of crap. So now, when you're flying ILS, if a DP, I've heard they don't want you using the map, they'll cut your map off. And so now with your DG processing so bad, your mag compass, you're not level in flight, so you can't really go on that. What is your best method for, maintaining your final approach course heading instead of having a fishtail all the time, you know what I mean, to follow your needle?
One word, bracketing.
Like last night we were talking about?
That's the answer to that question. That will solve your problem, 100%.
All right, I'll have to look into that more.
Yeah. Do you have a flight sim anywhere?
Oh yeah, yep.
Yeah, practice that.
Right there. I can't
Oh,
see it, but
sweet.
I got a nice one. It's a full Cessna cockpit.
Is that the Glime?
No, it's the flight sim wings from it's in Florida.
Okay.
Company over
So
there.
I have the Glime BATD FAA approved one. It's really nice.
Nice. Yeah, yeah.
But it's like 10 grand, but whatever.
Yeah, yeah. This
Don't,
one's
we
like
don't
6.
we don't talk about that though.
Yeah, no. This one's supposed to be FAA approved soon. It's pretty much it's damn near. I like it better than my Redbird at school because it's more tailored to the Cessna.
Oh yeah. So yeah, bracketing will solve that problem
Okay.
completely. Practice that on the flight sim.
All right.
I'm going to
And
show
that was
you.
Rob Machado, you said?
Rod Machado talks about it.
Right.
I'm going to pull up this. You're going for your instrument test. Your FAA, right? So let me pull this up. I'm going to share my iPad screen again, and we're going to look at the Airman Certification Standards. Now, this is for the FAA, so for the EASA guys, this may not apply to you, but the regulations are similar. The testing standards are similar, so this would be good advice in general. So I'm going to go through and see if I can find a point. So let's find cockpit procedures here. Let's see. I think it's in here somewhere. Instrument systems, flight instruments, instrument flight deck check. Says, and determine inoperative equipment, perform pre-flight inspection. Okay, that's pretty standard stuff. Compliance with procedures, holding procedures. Okay, get this. In the FAA, under holding procedures, it specifically says under the skills that you must demonstrate the ability to use an MFD and what? And other graphical navigation displays if installed to monitor position in relation to the desired flight path during holding. If you don't use a moving map on your check ride, he can fail you. Isn't that hilarious? If it's installed in the airplane, if your GPS has a moving map and a graphical navigation display, you can actually lose points on the test for not using that. So if your instructor is like, oh, you should turn off your map or whatever, don't turn off your map. I mean, sure, train for failures. Of course, you can fail anything, right? Train for failures, but realize that it says specifically use the MFD. And I believe there's actually a section here in the system where it says, let's see, use the MFD again, tracking and displaying things. What else? There's a section somewhere that specifically mentions EFB, electronic flight bag. I'm going to type that in and see. Okay. Let's see. If the applicant has trained using a portable EFB, so like ForeFlight, to display charts and data, and wishes to use that during the test, the applicant is expected to demonstrate the appropriate knowledge, risk management, and skill. So if you're using ForeFlight, you should be using ForeFlight and use it well and use it properly. Most of the instrument check rides that I have sent clients to have come back telling me that the examiner turns off the moving map display on ForeFlight. Cool, that's fine. So you might turn it off, right? But it doesn't mean that you still can't use your iPad to give you accurate information to help you out. So, yeah, does that kind of answer your question? It was about, you were asking about had to do with knowing your position, right?
Yeah, just so you're not chasing the needle when you can't rely on your mag compass or your DG because it's kind of processed, and you're just on the nearest page or your flight plan. So he doesn't want you to use a moving map either. He just, even though you say you did have access to it, what if he said, oh, it failed? You know what I mean? And
Yeah, so bracketing, that solves your problem.
okay,
So
yeah, I'll look into that. Thank you.
no problem. Yeah. Any other questions on that? Actually, you did have a question. It was about leaning on the yoke. So yeah, leaning on the yoke. If you just have good control over your yoke and don't death grip it, but also don't float your hands, right? You'll have good feedback and you'll be able to make that work. I had a student yesterday I was flying with, and he put his iPad in my lap for a second because he had to like pull a checklist out or something. So his iPad was sitting in my lap, and the controller tells him, "You're clear direct, initial approach fix, cleared for the approach," and a bunch of other stuff she said. And he like looks over in my lap real quick and is like, "What does that chart say?" And I'm like, "What are you doing? Stop. Just put your iPad in the correct position. Have your approach pulled up, know what you're going to do before you're going to do it, and then don't be surprised. Like you shouldn't have to, you shouldn't have to look at the chart every single time the controller mentions the final approach fix or the initial approach fix. You should at least know the name of the initial approach fix just from briefing the approach. It was very clear to me in that flight that he did not properly brief his procedure himself. Like I did not ask him to give me a verbal briefing. All I asked him to do was to know his stuff. And I could see he didn't know his stuff. So we talked about it. Let's talk about this last one though. And there's a lot more we can cover on the subject of cockpit management, but I think this kind of covered up a lot of it for right now anyway. We can kind of talk some more at another time. PTAC, position, turn, altitude clearance. This is how approaches or air traffic control gives approach clearances. They always give you a position if they're giving you vectors. So they'll say, you're 12 miles from this fix or whatever, right? 5 miles from this fix. Usually it's the final approach fix. They're going to give you a turn, right? So turn heading, 360 or whatever. They're going to say maintain an altitude, right? So maintain XYZ until established. And what does established mean? Established means that the CDI is moving inwards. The CDI is moving inwards, you are established. And then they're going to say, cleared for the approach. So air traffic control comes back and they say something like this. So the runway's here. Your approach looks kind of like this. The final approach fix is here. And you are out here doing this. Air traffic control says November 1234, you're 7 miles from, final approach fix. Call it, Twitty. That's the one we use a lot. You're 7 miles from Twitty. Turn left heading 170. Maintain, 2,500 until established on the localizer. Cleared ILS runway, 20 approach or something like that. Right? You don't need to read back 7 miles. That's not important. What you need to read back is 170, 2,500, clear for the approach. That's what you care about. That's it. 7 miles is an advisory, but 170 is an instruction. We got to be able to pick up the difference between instructions and advisories. Does that make sense?
Yeah, for sure. I've been doing a lot of VATSIM as well, and that's been helping.
Yeah, I actually am a VATSIM air traffic control instructor, which is kind of funny.
Oh, nice.
I used to do that a lot. I did VATSIM for 10 years maybe.
Wow.
I managed a bunch of stuff, like a air traffic manager for Hawaii or something crazy. But
That's pretty cool.
that was fun. And not anymore. But after that, I worked for Pilot Edge as an air traffic controller for 3 years. That was a lot of fun.
Oh, wow.
But so I can tell you a couple things about clearances. But anyway, it's the instruction you care about. So that's what I would say. And I would also say, as soon as air traffic control gives you that turn, start turning. Like before they even finish saying the 0 and 170, you should have that heading bug turned, or you should be rolling the airplane. So
cool. So established
cool.
is once that needle starts moving in. I always thought you had to be like dead nut center to be considered established.
Nope. If the needle's moving in, you're established.
Cool.
Yeah.
So when they say report when established, pretty much as soon as the sucker starts swinging in, say tower, whatever established on ILS, blah, blah.
That's exactly what I would do. Now, sometimes you'll get in a situation where maybe this right here is full deflection, and maybe you're shooting a VOR approach, and maybe the CDI doesn't go full deflection. Maybe it's like right here. Well, that's fine as long as the needle is in fact inside of full deflection and at least starting to move in. You can say, "Hey, I'm on the procedure. Like I am now joining this radial. I'm going in." So that would be established.
Yeah, I know someone who busted a check ride for they had to overfly the VOR and then turn off to start the DME arc in Florence, South Carolina, and they flew over the VOR and he made his turn when the to from flag switched. He didn't wait for the needle to swing in, so he busted it because he didn't wait for the needle to start swinging in. He just waited for the to from to flip.
Yeah, you'll get that on them big jobs.
Yeah,
that'll
that
happen.
that was just his instrument ride, crazy.
Okay, is that all you had for your questions, Adam?
Yeah, I'm good. Thank you.
Okay, was that helpful? That give you some good insight, or
Yeah,
did I?
100%. You did good.
Okay, if message me if you have any other questions on that, and I'll be glad to answer those.
Cool. Yeah, I'll
All
dig into
right.
them first.
All right, what else do we got? I've got several others in the chat here. I'm only seeing a couple faces, but let's go ahead and any insights on questions, comments, concerns that people have over any of this stuff. What are your trouble areas and how can we fix them practically? Remember, this is not designed to be instrument ground school. This isn't supposed to be some sort of pass your written test. This is supposed to be real world. How do I actually do stuff that works? Because if you can be a real world pilot on your check ride, you're going to pass your check ride. And you'll know how to fly in the real world. So I can give a lecture if you want me to. I can give a lecture about holds or something. But I'd prefer not to. So just go ahead. Anybody have any areas? Marco, what's some areas in your training? I know your check ride is either just coming up or you just took it or something. What's some areas in your training that you could use some help with if you can hear me? Still muted. Not sure if you heard me or not. That's fine. Let's see here. Jose, do you have anything? Maybe not. Emily, I think I asked you earlier, and I think you said no. Have you changed your mind since then?
Yeah, I thought of a question.
Okay.
So I understand like how GPS works and how it works together with WAAS, to kind of like enhance our GPS accuracy. Could you talk a little bit more, like about how WAAS just works in general, and like the difference between like the RNAV approaches, so like your LPV, your LNAV, VNAV, and like all those different types.
I love this topic. Yes, right now. Okay. This is the quality content we came here for today. Okay. All
Thank
right.
you.
No problem. All right. The question is the differences between WAAS and all the other things, as well as LNAV, VNAV, so on, and LPV. So basically, here's what WAAS is. Okay. So WAAS stands for Wide Area Augmentation System. Now, let's talk about why those words are important. So an augmentation system, okay, forgive the scribble, okay, is basically a system that says this. Our GPS satellites, let's say we have a GPS satellite here, 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 and I don't know, that's all we have, right? Our GPS systems eventually are going to, or will tell us, you know, hey, they say, okay, well, you are here. What they say. They say, okay, I'm here. They figure out my distance. We all understand how that works. It's just you have a radio signal that goes from the satellite to the receiver in the airplane, and that radio signal contains information. Now, if you guys don't understand how radio signals contain information, that's totally fine. Basically, a radio wave is a pulse of electricity that that can be picked up by like a magnet, and and think of it this way. There's a pole, like a metal rod that has some wires attached to the end of it, that those wires cause a pulse of electricity to zap from the bottom of the rod up to the top of the rod, and it goes back up and then it hits it, comes back down. And when it does that, it creates a pulse, right? You know, a pulse of electricity that goes all around the tower, the rod, right? And those pulses travel outwards. So that's where we get the waves from. We get radio waves and electrical waves. So the pulse goes up and down and does this, right? That's how the radio waves happen. Now, you can create these to be at a longer wavelength, a shorter wave length, where it only ends right here. You can have higher frequency, where it goes up and down a lot faster. That's a higher frequency of pulses, right? And you can even take these frequencies and these pulses and change them to where they carry information. And that way they carry information is through binary code. Binary code is zeros and ones, right? So 0, 1, 0, 0, 1, 1, 1, 0, 1, 1, whatever. And binary code is converted back into letters, numbers, and other information that we use in just computer coding. Like all computer coding is based on binary, right? So anyway, as these radio waves go up and down, you can change how fast they go. You can change how long they go. You can even change how high they go. So sometimes you might get a one big pulse here. That one big pulse might be a 0, and this tiny pulse here might be a 1. So the measurement of the pulses and how high or long they are can give us zeros and ones, okay? And those zeros and ones are converted by a computer back into code, which we use for computing, positions and things like that. So does that make sense as to how radio waves carry information?
Yeah.
Okay, cool. That's like the Mickey Mouse, stick figure version of how that happens. But that's the basics of that. So I'm going to clear out all of this and go back into some other things. I've actually had a lot of people ask me, they get really confused over navigation. They just don't understand how like GPS works, how radios work, which is understandable. It's going to be a very complex subject. So I try to boil it down to make it as simple as possible. So moving forward, augmentation system. Our GPS satellites all figure out that we are somewhere, about right here. Cool. The thing is they're only accurate within a certain area, right? We might be anywhere inside this circle, and the GPS thinks, okay, we're right here, is what it thinks. Cool. What WAAS does is it augments the position using ground-based navigation stations, which we'll talk about in a second, to give us a more accurate definition of where we are. So using WAAS, we can take the systems that the satellites from WAAS give us, which there are 3 bigger satellites above the United States, one here, and one here. These are satellites. These satellites beam information to our airplane to tell us, hey, you're actually right here. This is our accurate position because, all we knew from previous GPS is that we were somewhere inside this circle. Well, now the augmentation system augments our position from here to here where we actually are. So the airplane is actually right here. Make sense?
Yeah.
Okay, so that's what happens. The way it does it is this. We have satellites. Oops, hold on. We have GPS satellites that tell us, hey, your airplane is somewhere within, this circle right here. We think you're somewhere within the circle. In fact, we think your airplane is right here based on, the signal that we can give to you. We think you're right here. Cool. But we're not 100% sure because you're moving. There's no guaranteed position. So what WAAS does is WAAS has a whole bunch of ground-based stations. It's a little station right here. Just draw a little V. A little station here, 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 here. There's like 100 of them or something, 36 of them. There's a bunch of them. These stations have known latitude and longitude positions. So we know exactly where these stations are. And these stations have GPS receivers, GPS like RX, right? GPS receivers, just like the airplane does. So what we do is these satellites that are up here, these satellites here, ping information to these receivers right here. I'm just going to use this one receiver here for purposes of conversation. The receiver in this ground station says, hey, according to these GPS satellites, this ground station is located not right here, but it's actually located, right here. So the GPS thinks that we're located here, but in reality, we know because we have our known positioning, we know that we are actually in our original position, which is right here. You follow me so far?
Yeah.
Cool. So we know that we are here, or here anyway, but the GPS thinks that we're here. So because of that, the computer at the ground-based station calculates the difference. It knows the difference between where you think you are, which is right here, versus where you actually are, which is right here. And it takes that error. There's error involved in that positioning because these satellites here are not 100% accurate. They're close, but they're not perfect. But the latitude longitude is perfect that we have from our ground-based station. So it takes that error and it sends it up, and it takes this error and it telephones it using like wires and telephone signal and whatever, and it beams it all over to, let's go to blue, to these 3 a big like stations across the US. Like, it's a big building, like a skyscraper, like whatever, right? These are data processing centers. They process the data from all these stations across the country that collect the errors from the satellites. See, WAAS is simply a satellite like error detection and correction system. So it takes all that data, puts it into these big buildings. It does this every second. So every second, all the stations in the United States ping data from the satellites to these big stations here. Every second it does this. It's very, very powerful. The data from those systems is then processed in a second and then beamed back up using satellite dishes like this. It goes all the way back up here to these geostationary satellites. Geostationary satellites means that they do not rotate around the Earth. They stay in one position above a fixed point on the Earth. So while these satellites down here are spinning around the Earth really fast, the ones that are up here are so much higher up in outer space that the speed that they are orbiting the Earth is the same speed that the Earth is rotating. Do you follow?
Yeah, I do.
Yeah, cool. So because of that, it sends that information up here. And then these geostationary satellites, then they ping back to the airplane. I'm going to go like a color pink or something. They ping back to the airplane, zap, right here, and says, hey, you thought that you were right there. You are actually right here. It takes the error that we had down here and converts it to where the airplane actually is. So now we went from having, 5 meters of accuracy right here to now being accurate down to, 1 meter or less right here. So we're able to fly very precisely in the GPS system. Make sense?
Yeah, yeah.
That's what WAAS does. WAAS basically is the GPS saying, hey, the GPS satellites you normally get say, hey, you are right here. But WAAS uses all that to say, no, you're actually right here. This is where you are. Now, it's still accurate. I mean, you're still in the little circle, right? But you're down to super accurate instead of, just like right here. So
Yeah.
that's basically what WAAS does. Guys, drop a fire in the chat if that makes sense to everybody. And we'll continue.
Yeah, fire. But what was that red thing? What were the real red buildings with the dot in the center?
Oh, those are just the what are they called? They're not data processing centers. They're fixed GPS receivers. They're GPS receivers that are in buildings across the US that basically calculate the error between what the GPS satellites give versus what the actual position of the station is.
Copy.
So these stations know exactly where they are. But these satellites up here do not know exactly where they are. They can only get within a certain accuracy. So these GPS satellites up here guess where this station is, just guessing, hey, I think it's here. This station says, well, I know I'm here. Here's how much you were off. It takes this error, sends it to this big building here. That big building beams it up to this satellite here, which points it back to our airplane here and says, hey, you're off by this much. So that's that. Anyway, I can hardly read what I've written now, so we're gonna move on to something different. Okay, so your next question was about LP versus LPV, LNAV, VNAV, whatever. So let's go into that. In order to have LP, localizer performance, or LPV, which is localizer performance with vertical guidance, which, think ILS here, and think, localizer here. What does LP stand for? Localizer performance. So you get the performance of a localizer, which is very accurate, simply through GPS. And the way it's able to be that accurate is through WAAS. So LP approaches are WAAS only. You cannot fly LP if you don't have WAAS. So what does LP do, especially relative to like a standard RNAV or an LNAV approach? I actually have a video on this on my Instagram. You guys should go out and watch it. So look at it this way. On a RNAV approach, if this is the runway right here, and this is my center line on my approach, like this, when I am inside of the final approach fix, so let's say the FAF is right here. This is my final approach fix. Inside of the final approach fix, meaning anywhere from here to here, one dot of deflection is a certain distance away from the center line. I think it's this. If I go full scale deflection, which is going to say right here, full scale on an RNAV approach or an LNAV approach is 0.3 nautical miles from the center line. So from here to here is 0.3. And guess what? It's 0.3 whether you are, 5 mile final or if you are at the end of the runway. It's still going to be 0.3 miles. So, hopefully there's not a cell tower sitting right here that you crash into, because that would be bad, right? So it's not as accurate. But a LP approach is like a localizer, right? Where if the runway is right here and the center line is here, one dot of deflection, out here is only, this distance closer to the runway. So it funnels you in, you see, just like a localizer would, because it's a localizer performance. So, one dot deflection at the final approach fix may be, I don't know, a quarter of a mile off or something, right? While if you are on a 1 mile final or half a mile final, it might only be a few hundred feet off the center line. Does that make sense?
Yeah, for sure.
So it's localizer performance. It funnels you in. Think of it like a funnel. It just funnels you in down to the runway more accurately. And the same applies to vertical guidance as well. If this is the runway here, like this, and your glide angle is like this, a VNAV approach, which most of us don't fly unless we're flying, flight management computers in our jets or something. A VNAV approach, same idea. It just keeps you this same level of accuracy as you go to the runway. So if you're low, that could be really bad because, your 1 dot low might make you crash into the ground on a 3 mile final or a full dot slow or whatever. But of course, there's a decision altitude that you would level off at or that you would go around at. So you're not going to hit the ground unless you go below your minimums. But, there's definitely not very safe over here, right? But an LPV or an ILS funnels you in. So if you're, 1 dot high, you're still going to be getting closer and closer to the runway. So in this case, with the localizer performance, like LPV, it funnels you in, and you never hit the ground. Make sense?
Yeah.
So a localizer is, LPV is a combination of GPS and localizer. It's like an ILS and an
Negative.
RNAV put together.
Negative. This is GPS only, but it must have WAAS.
Oh, it's just acting like a localizer with the
Correct.
Gotcha.
It is a
Okay.
GPS approach that performs like a localizer with vertical guidance, LPV.
Copy.
Yeah. Emily, did you have another question on this?
I don't think so. That was really helpful. Thank you.
Okay, no problem. There was a question that was asked yesterday, I remember, about the differences between RNAV and PBN and like RNP and stuff like that. PBN stands for performance-based navigation. So it's basically taking your standard, point-to-point navigation like we would do on airways or different things, right? Where the airway is, 8 miles wide or whatever, right? And you have this much accuracy, see? To where you're able to have, with a proper performance in the plane, you could actually get down to, much tighter accuracy on your airways and even do curves, where previously you couldn't do curved lines in space. Like, you know how some approaches have the final approach point here and the runway is right here, but it might have like a fix here, and then it like curves to the end of the runway. Like a lot of Zulu approaches have that, like R&P approaches you guys have seen on procedures that has something here called a radius to fix. They can have these curves because they're using performance-based navigation with an R&P approved navigator in the airplane. So they can do something pretty cool with that. Any other questions? Don't be shy. We have a little time.
Yeah, one more question, Toby. Maybe you can explain how to perform a circling approach, and if you have tips
Yes.
and tricks on that one.
Absolutely. I love this question as well. All right, circling approach. So let's look at this, for example. Actually, I'm just going to draw it out here and give an example. So when we're flying IFR, right? IFR instrument flight rules is required to be flown whenever we are in instrument meteorological conditions. Easy, right? If I was going to fly from, let's say, I don't know, let's pick a nice airport somewhere. Let me get rid of these obstacles and take all this away so it's easy to look at. If I want to fly here from, let's say, somewhere in the mountains, I want to fly from, over here is fine, I guess. Dixon, so M02 to, I don't know, Smyrna, MQY. And I want to fly this flight. Very simple. If it's visual conditions, I would take off, I would use my eyeballs, and I would navigate using visual checkpoints on the ground and whatever, right? But let's say I get down to Smyrna and the weather is clouded in, right? The clouds, and I cannot land at Smyrna because I have to enter the clouds. So I file an IFR flight plan, I enter the IMC conditions, but now I have some rules to apply to. I'm not allowed to go below a certain altitude without hitting something, right? Remember, one of the first rules of instrument flying is navigate. And the second rule was what?
Don't hit stuff.
Don't hit stuff. Exactly right. Navigate and don't hit stuff. So if you can do those two things, you're going to be okay. The trick is, how do we do this? How does it apply to circling approaches? So if my airport that I want to land at is here, and the cloud layer, let's say, is up here, and my airplane is now up here, I have to find a way to get below the clouds to see the airport. That's how they did it in the old days, World War II and whatever. The whole point is navigate to some beacon that allows you to get down. And let's say that there's a VOR on the field. That VOR is, say, right here. It's a VORTAC or whatever, okay? And we are navigating on a signal from that VOR to get to the airport. This is not a vertical track. This is simply just the signal, okay? So we're able to navigate to this airport. So, we begin descending down and getting down below the clouds. So we descend the airplane on our approach, and finally, yay, we're below the clouds, right? But we have to level off. Or we don't have to level off. We could just stay right here. We're below the clouds. Great. And we see the airport. Wonderful. So what would we do? We could either go VFR and cancel IFR, right? In which case, what would we do? We would join the pattern or the circuit, and we would maybe cross midfield and do something like this, and then come in and land or something. We would join the circuit and land. That's the same exact thing that you would do in a circling approach. A circling approach is the same as you just joining the pattern or the circuit. The only thing that's different is your altitude. The average circuit, at least in the United States of America, is 1,000 AGL. Right? Generally, for your average, single engine piston airplane, 1,000 AGL. But the average circling approach is much lower. It's closer to 500 or 600 AGL. So let's say that I am coming in to land on this runway here. And my approach, on an RNAV approach, is designed to take me to the end of the runway. But the wind, of course, is blowing very strongly from this direction. And I need to land on this runway here to avoid a tailwind. So I know I need to circle, right? And of course, it could be any variety of things. It could be a VOR approach where you're coming in at an angle, and you have to circle to any runway. It could be anything, right? But in this case, we're going to come in from this RNAV approach. And I say, okay, I have the runway in sight. I'm ready to circle. Well, I'm at 600 feet here. What do I do? Simple. Once I get within my distance for circling, which we know in category A, right, is 90 knots and less, is typically 1.3 nautical miles, at least in the FAA. So when I am 1.3 nautical miles from the runway, right here, I would begin to circle. What does that look like? I'm just going to join the pattern. Whenever I'm flying the jet, I just turn 30 degrees like this. I just turn 30 degrees, and then I join myself on the downwind and fly a low downwind. Now, of course, I'm much lower. I'm at 600 here. So I don't want to turn base immediately like I normally would. I don't want to start descending right here at being the numbers like people usually think you would do. That's very dumb. You're already too low, right? So my thought process here is, where would I normally be 600 feet in the pattern? Well, I know I'm usually at 1,000 right here, and I'm going to be descending around the corner. Usually, I'm around 600 feet AGL, usually about here on base, wouldn't you say? So I would continue flying the airplane at 600 AGL to where I normally would turn base, and then on base, when I'm at the point where I'm usually at 600, then I will begin my descent and join final and make a normal approach. That's what I would do in this instance. The trick here is to not descend. The hardest part about circling is to not descend. You need to stay at the MDA until you get to here. Stay there until you're ready to make a stable descent. Some other options for circling might look like this. Let's say the runway is here, and our VOR or whatever that we're using to navigate is here, and our inbound course, looks like this. Well, how do I circle to this runway? Well, which runway do I want to circle to? I may be able to, once I get inside that bubble from the runway, the 1.3 miles or whatever it looks like. Once I get within this distance, I could say, well, I'm going to just turn this way and join a right base, and I'm going to land. I can do that. Or what if I don't see the airport until right here? Well, maybe what I could do is cross over midfield and join downwind, base and final. Or go the other way, right? Sometimes I've even seen this happen, where an aircraft will go ahead and, let's say they want to land on this runway right here, but it's not a good idea for them to cross over midfield because they can't see the airport as well. Or maybe they shouldn't turn base because it's too high or something. Maybe they need to descend. They need to lose some altitude. Like, remember at Aspen, the Aspen airport was kind of like that, where you come in, you're 2,400 feet AGL at Aspen, trying to circle. So you can't just drop down and do that. You have to do something different. So what you might be able to do instead, which I've seen people do, is actually to join the upwind, then turn crosswind, then turn downwind, then turn base, then final. You could do that if you wanted to. There's a variety of things. The whole point is you're doing a low pattern slash, circuit. And that's it. Do it at the MDA and descend when the MDA meets your glide path to the runway. So that's my tips on circling right there. And when you're going missed approach, this is a common question. How do I go missed in a circling approach? So let's say the missed approach procedure for this approach here is to do is to climb out on this heading, and then to do at a certain altitude, then turn right or turn left back to the VOR, and then, hold or something like that. Let's say that's the missed approach procedure. But let's say you go missed, say right here. You decide right here, I need to go missed. So what do? Well, you circle towards the airport while climbing, right? That's what it says. So you would turn towards the airport, which you know is here, while climbing to the missed approach altitude, which let's say that's, I don't know, 3,000 or something like that. Climb to 3,000. You already know that the radial that you're going to be joining is right here. So I would continue to climb to 3,000 feet. And once you know that you are at a safe altitude to turn, which would be immediately, because if you are over the airport right here, you know there's no obstacles right there at the airport. I mean, you're not going to hit anything, right? There's no one puts a giant tower right in the middle of an airport unless it's the control tower, and that should have already been determined. You know where the control tower is. So I would simply climb towards the airport, and once you feel it's safe to turn, I would turn simply in the heading, just the heading of where the VOR is that you were going to initially. And then once I know I'm past the VOR, I would continue climbing and then turn back direct to the VOR. I might not be on the radial. I might be over here when this happens, but that's okay because I know I'm not going to hit anything. Remember, don't hit stuff, right? And then once I'm at the safe altitude, like it says, I'll simply turn back around and go direct to the VOR and, do a teardrop entry like I should do, and then do my hold. So that's how I would circle from that. There's an example of an approach that I fly semi-frequently that we circle to. It's here at Springfield Robertson County Airport. I showed this airport to you the other day when I was talking about the approach that I almost failed my instrument check ride on back in the day. It was this one here. So how do you circle from this approach, right? So the circling mins are 1180 and 1, which puts me at 474 feet above ground. So very low. If I was to circle from this, and I was to circle to runway 22, I would break off here and I would join the downwind and then circle. And let's say I'm right here and I need to go missed. Well, how would I do that? Right? What would I do? Well, I'm already on final, so I don't really have to turn towards the airport, right? So what I would do in this case is I would fly down the runway. I'm towards the airport and I would climb. I would climb. Once I climb, I would climb to at least the MDA. At least the MDA, because I know that along this line here, the MDA gives me guaranteed clearance of obstacles, and the MDA gives me guaranteed clearance within 1.3 miles of the runway. So anywhere inside the circle above the MDA, I'm safe. Agree? I'm safe. So what I'll do then is once I'm at least the MDA, then I will turn the airplane in the direction that I know is safe, because I should have briefed this before. I know there's more towers over here and there's more towers over here, but they're far enough from the airport, and the MDA is above these towers. So I will turn back to this heading, whatever that heading was. I may not be on the line, but as long as I'm in the same direction, I'm good, because the procedure says to join this radial. So I'll just join that radial and go from there. Make sense? Okay, very good. All
Yes.
right.
I had one little thing about the circling that I had stuck in my brain, IFR, everything's standard rate. So when you're in the circling, you can do 30-degree banks. So a couple times I would overshoot my final because I was just going standard rate. My instructor's like, dude, you're visual now. You can go to 30 to make your your base to final turn if you need to.
You can go to
What are your
90
thoughts?
degrees if you want. I don't care as long as you're
Yeah,
stable. But
yeah, yeah.
90 is probably not stable. So,
Yeah,
you
yeah.
know,
Because at that point when you circle, you are visual, right? You're not IFR anymore. You're supposed to be. Is that what the whole
well,
thinking of it
you're
is?
operating under instrument flight rules, but instrument flight rules does not dictate how you turn an airplane. You can, heck, if you wanted to fly 45-degree bank steep turns when air traffic control gives you a turn to final, have at it, man. It's stupid, but have at it. You know, that's completely up to you. The whole point here isn't let's fly some super precise turn. Air traffic control doesn't care. The FAA doesn't care. They want you to not die. Do what you can do to not die. Because if you die on their procedure, they're getting sued. They don't want to be sued. So do what you got to do to not die, and you'll make them really happy. And yes, when you're in the soup, you should not be turning more than standard rate normally, unless you have to. That's not a regulation. That's advisory. That is the FAA telling you, we want you to survive, so we're going to tell you to fly standard rate because if you do this, we know it's safer than doing this at the final approach fix. So that's what I got on that one. I have a video I want you guys to watch. I don't have time to show it all to you now. I'm going to pull it up on my computer here. I need to find YouTube. Give me one moment to pull up my YouTube, and then I'll show it. It's very good. This is one of the best courses you'll ever see on instrument flying. In fact, I think it's actually in the school course. So I'm going to go to school instead. Let me do this. New share school. Okay, so you guys can see the school page, right? So in the classroom, you'll see a bunch of trainings and there's a bunch of stuff down here. You can ignore all that. I don't think you have access to it, but the IFR call recordings are here. So you can click on this and you can see the recordings that we've done. And on the DME ARCs, I put some other material down there for those nerds that want to know all the math behind it. But we've got several hour-plus videos all in here. In today's video, I'm going to upload this immediately. So this will be on in just probably an hour or so. But if you go to the classroom and you see, I think it's instrument, maybe weather. Weather's a good one. You'll see these 1940s and 1960s training films. Now, these ones are on like weather, like ice and fog and stuff like that. But I've learned a lot about just instrument navigation by watching how these older pilots back in World War II and in the 60s, how they would plan their weather. Because they would plan for weather based on what they knew they could navigate with, which oftentimes is just a single bearing to some radio station and an altitude, and that's it. They didn't have, approaches, as much as we do. All they had was, I hope the clouds are low enough or high enough to where when I get close to the airport, I can descend and see the airport, in which case I circle down to the runway, right? So these are very good. I'm going to see if I can go to this. I'm going to play a little bit for you so you can see. It's awesome. It's like Walt Disney actually it is Walt Disney. Walt Disney made this video for the United States Navy in 1943 or something like that. It's wonderful. It's like watching Bambi or something, but you're watching it about airplanes. It's great. So if I go to this guy's channel, Periscope Film, it's very cool. I'm gonna go find his content. Oops. So let's see if it's playlists, his NASA films, other things here, historical films. Let's find it. Where was the ones? There's a lot of playlists. Ooh, the Gemini mission. My grandfather worked on those. I don't know. I don't know where they all are. But there's a bunch of these that he has on World War II and old aviation type of things. So you can find that on here somewhere. I gotta find it for you guys. It's so good. So cool. Where is it? X-planes, cutting edge aviation stuff. There's one where he teaches you how to fly a P-47 Thunderbolt. Like it's this black and white video of a fighter pilot during World War II getting trained to fly a P-47. He's going through all of his checklists and all of his procedures, and he literally it's a single seat airplane. So his checkout was himself. So when you're a World War II fighter pilot and you learn to fly, on the AT-6 Texan or whatever, and then you go transition to a fighter, you teach yourself how to fly the fighter. You read a manual that's about this thick, maybe a few pages, a brochure saying, hold about this speed, this system's over here, you're going to want to watch for this. And they would say things like, yeah, this airplane handles pretty easy. It's about like the trainer, and you just got to make sure you don't flare too hard, and that's it. And they would go fly based on that, and they would be absolutely wonderful pilots. So I'm going to send you the link to this stuff. But you can actually find this in the classroom here. So just find the guy's channel. There's one also by Airboyd, a couple of them by him. So a lot of great training videos on just the basics of radio navigation. Of course, these are weather, but that's what I would suggest you go look into. So, any other questions? Pico, yeah, it's in the mastermind. So go, if you're not in the mastermind already, go join it. It's free. And then go to the classroom and you'll see a section where you can watch those videos. So any other questions, comments, concerns, takeaways? What did we learn? Della, go ahead.
Hey, Toby. How are you?
I'm great. How are you?
I'm good, man. I'm on my way to flying right now, going to my airport. Just a little bit concerned on some procedure turns or any course reversals on an approach. Do you have like any tips or any knowledge that you could educate me even more?
Yeah, it's easy. It's easy. You just gotta fly good and don't suck. That's it.
Okay.
So, I mean, if you just stop sucking, it'll be great. I'm just kidding. No, go ahead. I'll show you some tips on that. Procedure turns are probably the easiest thing you could ever do if you don't think about them so complicated like everyone else does. See, everyone overcomplicates this stuff, guys. It drives me up a wall. It makes me want to pull my hair out as to how complicated instructors make everything. So let me pull this up in my iPad and I'll draw it out. It's so bloody easy. Where is it? QuickTime share. Okay. Procedure turns. Go down the list. And after this lesson, I'll answer a couple more questions, easy questions, and then we'll upload this and go because I need to get some lunch. I try to keep these at an hour, but you guys ask such good questions. It's like, come on, what can I do? All right. Procedure turns. Here's what you need to know. The first step to mastering procedure turns is to stop calling them procedure turns. I know, they're called procedure turns, but it's stupid because it makes it sound super procedural and super technical, and it makes you confused because you think you have to make it perfect every time when in reality you don't. It's a mindset thing. I'm actually in the process of writing an entire course all about IFR mindset. Anyway, I won't talk about that. Instead of calling it a procedure turn, call it what it actually is, which is a course reversal. Well, AL, okay, whatever. Okay, course reversal. That's what it really is. Sure, it's the same thing. I get it. But if you call it a course reversal, your job becomes eminently clear as to what you should do, and abundantly clear. So think of it this way. You are on some kind of radial. going from, or of course, whatever, right? Going from some kind of station. Let's just make it a VOR because, you know, that's what we're used to. So you're going from some kind of station. Let me get my pencil working correctly. And you are here. And you now find yourself in a position where you would like to not be there anymore. You would like to be reversed. You would like to be, oops, here instead, going this way. How does one do that? Okay, how does one turn from this direction to this direction? So let's think about this. A lot of guys like to make fun of me because of how simple I boil this down to, but I'm like, it's really, this is how easy it is. Airplane, fly this way. Airplane, no likey, fly that way. So airplane, turn around. When airplane turn around, airplane now lost because airplane not on radial. So that doesn't work. So instead of airplane turning that way, airplane turning the other way now. So the way we do a course reversal, we got 3 types of course reversals we can do. You can do anything you want, but there's 3 that we mainly use. The first is you've got a teardrop course reversal, you've got a 45-degree course reversal, and then you have something called the 80-60. All of these are designed to reverse your course. So here's what it looks like. Let's look at the teardrop one first. This is the one that we rarely ever use, but we'll talk about it. You decide I need to turn around. So what you do is you start turning 30 degrees off of whatever your course was. You just turn 30 degrees away for 1 minute. Well, why do we go 1 minute? Well, because if I did it at 5 seconds and I turn back around, I'd be lost again. So I need to be able to get myself some room from the radial. Now, I know technically I'm not lost. I can just turn back this way, whatever, okay? But that's what we're doing. You turn 30 degrees out for a minute, and then you simply turn back the other direction. When you do that, you join your radial. That's it, right? The 6 T's are very important, turn, time, twist, throttle, talk, track, then, tires, like the other guy said, like John said the other day, right? So you do your 6 T's or whatever, right? So I make my turn. I turn 30 degrees out. I fly that heading outbound for just long enough to get away from the radial. And dude, we can get rid of the whole numbers thing. We can get rid of 30 degrees even. We don't even have to talk in measurements of degrees and time. All you want to do is turn the airplane this, oh, I keep erasing it. I'm so sorry. Is turn the airplane this way, get away from the radial, and then turn back around so that you can then join the radial this way. That's all you're doing. So that's literally all you're trying to do. This would be a standard course reversal where you turn 45 degrees for a minute is standard, right? After the time expires or however long you want it to be, turn the airplane around. Twist to the inbound and fly that radial. That's it. So I'm going to erase this and say it one more time with using even simpler language. Let's see, here we are. The VOR's here. I'm going out. So what I'm going to do, I'm going to turn 45 degrees this way. I'm going to go away from the radial. Once I'm far enough, I'm going to turn around. On that turnaround, I'm going to twist from the radial going this way to the radial, oops, to the radial going this way. When I'm here, I'm going to join the radial, and that's it. Just join it. You've reversed your course. Congratulations. An 8260 is similar, where what you do is you fly outbound, you turn the airplane 80 degrees of heading change, and as soon as you get to 80 degrees of heading change, so almost 90, but not quite, you immediately turn the airplane, standard rate turn, back to your inbound heading, which should put you, right on the line. That's it. And remember, technically, a hold is also a course reversal. Technically, right? Right? Where you're coming down on the hold, get to your point, and then you just simply turn around. And then you fly this way for as far as you want to fly until it's time to turn back to that radial and join it inbound. That's it. Does that kind of answer your question? Does that take procedure turns and course reversals to a level that makes more sense? You cut out there, Della. I think your internet is having a problem. Anybody else?
Now. What's that?
Sorry, you cut out significantly. I didn't hear anything for the past 10 seconds. But does that make sense? Does that really clear up your course reversals for you?
Hey, can you hear me now? Oh yeah. Thanks, Toby. I'm
I
about to
hear
go
you.
fly one actually down to Gillespie right now.
Perfect. I see that. This man is committed right here. Perfect.
Sorry. Let me just mute this real quick so I don't bother you.
That's fine. I just want to make sure that you understood what I said. I didn't hear if this all made sense to you.
Yes, sir. Yes, sir. It did make perfect sense. Thank you so much for expanding my knowledge on procedure terms. I won't call it procedure terms anymore. I'll just call it course reversal. So thanks.
It makes so much more sense. Perfect. And one thing I'll mention before I get to Sanders' question is a hold, for example, same idea. On a hold, we don't really care about making it a perfect circle or anything. In fact, all air traffic control cares about with a hold is the fact that you hold on this radial to this point, do all your stuff, on this side of the radial. So heck, if you wanted to hit the VOR and then turn 90 degrees and then turn 90 and fly a box, like no one cares. It doesn't matter. All they care is that you get back to this point and fly it inbound on this side, not this side. That's all they care about. So get to the point, reverse your course, find a way to get back to this point right here and repeat the process again. So there's that. Xander, you had a question, sir.
Yes, and maybe you can explain if you need to correct for a wind during the course reversal procedure turn.
Sure. Same thing as before, right? So it can be very overcomplicated, how people do this. Let's say that we're doing a course reversal. The VOR is here. We're flying on this radial. And, we start here and we're going outbound, right? And let's say we have a strong wind from this direction. This is the common one. We get a strong one from this direction. The other direction, could be the same thing, but it depends on which way you turn, right? So let's say that the barb on our approach is like this, so we have to, do it on that side, right? If we do our course reversal into the wind, you'll notice that the wind is going to push you in closer. So where you normally would have done something like this, whoops, where you normally would have flown out for, say, this distance, right? Well, now that 1 minute might only take you this distance. And then on top of that, where you normally might have turned like this to get back to the radial, it now looks like this. See? And you're much closer to the radial now, and it can be easy to, blow past it while you're trying to turn in, right? So it's very common. My suggestion here is if you have a strong headwind on your course reversal, maybe fly a little bit longer than 1 minute, maybe. And then prepare yourself to be blown like this so that when you get to right here, all you need to really do is join that radial, even if it's not pretty. Because here's the thing, at the end of the day, what do we care about? All we care about is getting back to the radial. So everything being pretty aside, take your airplane, fly it this way, do what you have to do, and then get back on this radial. I don't care if you have to join it at a 90-degree angle. I don't care if you have to join it at a 10-degree angle. I don't care if you blow past it a little bit trying to correct and you have to join it from this angle. All I care about is that you get on this radial going this way. Think about it. Xander, if I took you and put you in an airplane and I said, Xander, you are on this radial and you're going, this way or whatever. And I said, I want you to go fly this heading for a minute or two or whatever. And the airplane ends up somewhere, somewhere over here. And I say, Xander, I need you to turn back around and join this radial. What would you do? You would take the airplane, you would look at your CDI, you would see that, oh, the CDI here is selected to, 180. I am west of the station, right? So the CDI needle's all the way over here, and it says, 090 right there. So you, like the good pilot that you are, would turn the airplane to that heading, which would put you, somewhere pointing this direction. As the needle gets closer and closer, eventually it's going to center, in which case you'll be there and you'll just simply fly 180. Guess what? This is a course reversal. Now, is it a good one? Not really, not really a good one, right? But it is a course reversal. We reversed our course. Now, there are a couple little rules that we have when doing course reversals in general, and that is instead of, turning 90 and then going this way, which we could do, it is a better practice. It's better airmanship. It gives you better accuracy and better, consistency to go a shallower angle and to turn towards the outside instead of the inside, because it gives you more time to set yourself up instead of now being this much closer to the runway. See, does that kind of answer your question on the wind correction, Xander?
Yes, it did. So what about the 80 to 60? Do we need to apply wind correction there, or is it?
The 80 to 60 really only works when there is no wind. But even then, on the 80 to 60, if you're doing one of those and you go out like this and then you do this, if you get blown over here a little bit, like this, well, what are you going to do? You just come back and rejoin. I mean, that's the thing. Worst case scenario, you fly a new heading and rejoin. You're still going to get back to the radial. Everybody in the chat, raise your hand if you have ever gotten scared that you were going to just mess everything up because you blew past a radial.
Yeah, I had a bunch of those.
Yeah, everyone's going to raise their hand because everyone's experienced it. I'm here to tell you, stop freaking out over it. It's not a big deal. The big deal is you getting back to the radial. This is what I want you to do. I don't really care what happens over here so much as long as you get back on this line. Yes, there are more accurate ways to fly. There are ways to be better and be more precise. And yes, I would like you to use some good common sense. And you will find if you have this mindset, you will naturally fly better. You will naturally fly better radials. You will fly better, more precise procedure turns. It'll be wonderful. Like you will do the standard, procedure turns that everyone wants you to do, and it'll be okay. It will be, good, right? However, as different things in your aviation career happen to you and you get blown off by the wind a little bit or something, or whatever happens, that's okay. You're not going to worry, because at the end of the day, you're just trying to get back to this radial. So that is the lesson on that. Okay, any last minute questions, comments, concerns, corrections, anything that I may have said or done incorrectly that needs to be addressed?
Well, I got a question, but it's going to take a lot more time to probably, so maybe for next time, talk about like the fake thing that everyone talks about, reverse sensing for VORs. It's more just like, obviously I'm not gonna ask you about it right now. You know what I mean?
Yeah, first of all, reverse sensing does not exist. It's
I
fake.
know.
Right. So just go watch the last video. Were you at the last lesson we talked about on that?
Yeah, man. I still don't I watch video on video. I don't know why my brain's not grasping it. I'm just, yeah.
Okay, I'm gonna break it down. I'm gonna do it right now. This will take 30 seconds. Okay. Well, maybe 45 seconds, but whatever. Okay. Reverse sensing. Okay. I'm really hungry. I've got to get some. I'm getting some barbecue. Honestly, you should Venmo me for some barbecue, because I'm about to go get a big old rack of ribs, like this big.
Hell
Okay.
yeah.
No, don't Venmo me. I'm kidding. But reverse sensing. So VORs and localizers, basically anything VLOC, right? Like we know what VLOC is. Anything VLOC. Left and right does not exist. Does not exist. What exists is bearing, course, radials, and track. These exist. Left and right direction does not exist, right? And like the compass or whatever exists too, but I guess that's track covers that, right? So I wonder, do I have the VOR simulator on my iPad? Oh, yes, I do. Oh, darn it, man. Come on, that is not fair. Okay, so I don't have that app anymore. Let's just, I think I have an image I can use for this. We'll look at this one here. I'm going to edit this, revert. Oh, no, let's just, yeah. Okay, perfect. We'll look at this one right here. How do I make the marker work on this thing? Edit and marker. That works. Okay, perfect. Excellent. Okay, so you currently do not know the heading of this airplane, correct?
Yeah, correct. Because it's GPS. That's kind of like fake, and just an advisory that you set the OBS in the.
Yeah, like you currently have no idea what the heading of this airplane is. You just don't. Okay. Now I know the heading of this airplane because I flew this airplane, but you don't know the heading of this airplane. But if I said, hey, I need you to join the the 210 radial outbound on this VOR down here, what would you do? What do you think? Just if I said fly the 210 outbound, but do not touch the OBS. The OBS doesn't work anymore. What would you do? And 210 is already selected on the bottom side, so let's just pretend it's already centered. Like this number is here. What would you do?
Turn left. Drag the needle, so you're flying away from the
Well,
number.
there's no left or right. There's no left or right. You have no idea what your heading is. There is no
Oh.
left or right. Remember?
Okay.
The answer to the question lies within three things. The first thing is the needle. Which side is the needle on? In this case, the needle is on this side here. See that? The needle is there. So that means the VOR radial, like the rate, in order for us to get to that radial, we have to fly somewhere on this half of the instrument. So if we fly 330, we're going away from the radial, right? Like you understand that, right?
Yeah. Oh yeah, yeah, yep.
Yeah. Okay. Sorry. I always have to ask. I'm not trying to sound passive aggressive or condescending to anybody ever. But I have to continue to ask to make sure, because sometimes people have been so brainwashed with how VORs work that the terms are all off and they just don't know what they're talking about, right? So I'm like, are you tracking? Okay. So we understand in order to fly to this radial, I have to fly any heading, or sorry, any course, any track between 030 this way to, the 210 or whatever. Technically, if I fly this or this, I'm just going to parallel it, but I'd fly somewhere over here. So here's a question. What is the quickest way to get to that radial?
To 210 radial?
Yes.
I would, so you have to intercept your needle, so you just make a 90-degree turn.
Which would put me on a course of what?
Looking at this one, 120.
Exactly. Just follow it all the way across to 120. Cool. So I need to fly 120 to get to this radial. Now, this radial, we can talk all day long about the to from, and it's fine, but we understand this as being a radial. The longer, I'm actually going to make a video on this sometime. I want everyone to listen to me. This is very important. The longer that I spend as an instrument pilot and instructor, the more and more I move away from thinking about VORs as points to navigate to. And instead, I begin to think about VORs as simply radials, courses, lines in space. Like, this is a line in space. The VOR is somewhere on this line, somewhere, right? But this is first and foremost a line through space. My job is to get to and navigate on that line. Like, that's what I care about. Once I'm on the line, then I can figure out, okay, am I on, this side of the VOR? Or am I on this side of the VOR? Like, where am I, right? That's where the to from flag comes in. But all I care about is getting to this line, okay? So I'm going to clear out all the stuff that I just drew. There we go. So how do I get to this line? That's the question. And you've established correctly, we need to fly 120 to get to that. Cool. So now we get to it, the line, the needle centers. And now we are centered right here. So the needle is centered in the middle. And I'm just going to draw that as a white line just to make it, real correct and everything. Needle centered. And this over here doesn't exist anymore. It's gone. Okay. Now you want to fly the 120 radial. Now what? The question is, do I want to fly the radial from? Which, remember, 120 radial only exists on one side of that VOR, right? It only exists on the side where 210 is, right? This is the 210 radial. This is the 030 radial on this side, right? The opposite side, right? But both of these courses are selected by my course up here, right? You understand that, right?
Yep.
Like, it's the same line. Like that long line I talked about, it's the same line. Like, this line is the same as this line. The only difference is which side is a to from flag on. So regardless of the to from flag, we see this. The needle centers on this radial. Cool. If you want to fly the 210 radial, which course will you now fly?
Which course would you now fly to fly 210 radial?
Yes,
When you're on a heading of 120?
No, so you were on a 120 heading for a while, but now the needle centered, like right here, needle centered.
Gotcha.
So it centers. Now what do you do?
You would turn left to go
There's no left or right. Left and right does not exist.
Oh, okay. So you fly the 210 heading.
Yeah, track, course, not heading, a wind, whatever, right? If
Yeah.
we say heading, we mean course. Like we understand the difference between those two.
Yeah.
But yes, you would fly 210. Why? Because you selected this line. You are now somewhere on this line. We're not sure which side of the line you're on yet, but you're on this line, right? Now, if you're on that line and you want to fly 210, well, the correct answer is to fly 210. So you would turn the airplane, whichever way is required, to fly a 210 course, which in no wind would be a 210 heading. Clear as mud, right?
Yeah.
Right? That's what you would do. And that needle, let's say the needle moves to the right because the wind blew you off a little bit. In order to get that needle centered, what is a course you could fly?
Sure. 200.
Yeah, 200, maybe even like, 180. It's a good little, 30-degree intercept angle there. You fly that until the needle comes back in the middle. And then you get back to 210 or maybe a little bit of wind correction so that it doesn't happen again. Notice how we navigated to this radial without ever twisting the knob or looking at the to from. All we did was say, there's a line that is over here. I want that line to be right here. And then on that line, I want to fly 210. So I flew it.
Yep. And that's why you're saying it's no reverse sensing, because you just got to look at it upside down. It's not reverse sensing.
Yeah, exactly. Exactly. Now, that being said, if I want to fly 210, yeah, I'm going to go ahead and spin 210 on my OBS because that makes it a lot easier to look at.
Yeah, for
right?
sure.
Because you see it left to right. It makes it easier to just like visualize it. However, all I need to know is the fact that the needle's over here and I want to fly towards it. So I'm going to fly this. Easy.
Yeah.
Now, I can tell which side of the VOR am I on, right? So I have a 030 indication 2, meaning that in order to fly to the station, I have to fly 030, which 030 is this way, but I'm on the other side. I'm going to the station, so that means I'm over here. So I'm actually on the 210 radial right now. So I know I'm on the south side of the VOR because of the 2 indication. That's how I always do this. So I'm going to do that one more time to show you guys how it works. If you want to know where am I in relation to the VOR, like where's the VOR, what's going on? I say, okay, the VOR is here. I'm showing 0302. So let's go ahead and draw 030. 030 is up.
Hey, Toby, I gotta go, but thank you. I'll catch up tomorrow in same time probably.
Okay, no problem, dude. We'll catch you.
All right, thank you.
So I draw the VOR. I say 030 is up here. I just draw a line through the VOR, straight line. That's it. Now I see it's going 2. So 2, the station, is on this side. So I know I'm somewhere down here.
Yep.
Is that
No, yeah, I got that.
Yeah.
It's just really because it's one. I was flying on my simulator in Florence, South Carolina, where I'm taking my check ride. They have a circling or a VOR, alpha approach, and when you leave the airport, he wants you to fly directly over on a 052 radial, and then break off whichever way you're going for the DME arc or your procedure turn. But then so you're on your 052 radial, and then whenever, I think it was when I came back around for my procedure turn and I passed back over the VOR, it started reverse tracking, or opposite tracking because I didn't switch it to the inbound course. I just left it on the outbound course. And whenever I crossed back over the VOR, it started doing the funky stuff. But,
Sure. Well,
But
I
yeah, so
always do
this
this,
helped.
man. I always figure this. This is the easiest way to make this work, and I'm gonna show you. It doesn't matter. Like what, don't think about what radial am I on. Think about what course do I want to fly relative to this VOR.
Mhm.
If I want to fly to this VOR, like on 030, or it doesn't matter if it's 030, I figure out, do I want to fly 030, you know, and go to it or from it? Doesn't matter. Like I want to fly this direction. Back this up. I want to fly in this direction relative to the VOR. It's a from over here, right? And it's a to over here, but I don't care. I want this direction to be on my HSI or my CDI. Then you already know, like when the radial comes up, what you have to do. If it says 030 and you're down here, well, when that needle centers, you already told it that you want to fly this direction. So you just turn that direction.
Yeah. Yeah. So what I started doing was I set my outbound head radial 052 in the top CDI, and I'll set the inbound course on the bottom CDI that doesn't have glide slope on it because you're only doing the localizer anyway. So I'll come back, I'll follow that on the VOR, then I'll break off procedure turn, come back around, and just wait for the bottom needle to swing in. And I just follow the bottom needle all the way in, and it seemed to be working pretty good.
What approach are you doing?
Florence, K-Flow, KFLO, and some the VOR alpha. Yeah.
Okay, so you get to Florence VOR, then what?
So pretty much I depart off a runway. It's pretty much the leave, or I guess wherever. He wants you to hit the VOR and then break off, whether you're doing whichever IDEBI or JONAP or the procedure turn. But he wants you to fly directly to the VOR, wait for the reversal to from, and wait for the needle to start swinging in before you can do your turn any which way you want to go. So what I
Is that
would
your
say,
instructor or the DPE?
DPE.
That makes no sense. I think it'd be better to, like, let's say you take off runway 18 or whatever, right? Just take off, that's 18, right?
Mm-hmm. Or
19, whatever.
19.
Close enough. Same thing, right? So take off, go to the VOR. Cool.
Yep. That's exactly what he wants.
Right? So once you go there, I mean, here's the thing. Do what the examiner wants, okay? Because you want to pass your check ride. Okay, let's just be honest. Okay. But there's also he legally he can't fail you if you just turned on the radial immediately, but whatever. So what I would do is I would say, okay, across the VOR, I just got a from indication. As soon as it says from, I am immediately twisting to 006. Like the CDI will say 006, like immediately when I cross the VOR. I twist it. And then I look at it and say, okay, well, I'm probably on this side of it now, which means the needle's probably over here.
Yep.
Right? So what I'm going to do is I'm just going to fly a 006 heading, or if I know there's a lot of wind, I might correct a little bit, right? But I'm going to try to fly a 006 heading until I see the needle kind of like, twitch a little bit. Because, when you're first over the VOR, it's very sensitive. I might even fly 10 degrees, something like that, right?
Yep.
Then when it centers, I'm on it, I fly outbound.
Yep.
That's what I would do.
Exactly. Yeah, no, I got all that. It's mainly coming back in on the arc. So say then when I go to back around to hit the 052 radial, say, and then you have to come back over the VOR. Whenever I cross back over the VOR inbound, if I left my 052 radial on and just rode that in, it was fine. It didn't sense any. It tracked normally until I crossed over the VOR. Then it started reverse tracking.
No. So here's what yeah. Okay. Yeah. Yeah. When you get to Vito, what are you twisting to?
So that's what I was saying. Now I just have two CDIs set. The bottom CDI I just leave set on 232 and just wait for that to swing in. where so I'll use my top CDI to set it to 052. So when I take off, I can intercept the 052. And then like you said, I switch to the 006 or the 088 radial whenever I get to the VOR and ride that out to 7.5 DME. And then I start my inbound turn left to right to ride the arc. And then when I'm coming into VIDI, I just watch my bottom CDI, that 232 heading to swing in. But before that, I was doing just trying to fly off one CDI, and I would just leave the 052 and just intercept that because it's, you're intercepting whatever. And it worked fine. It tracked all the way down to the VOR, normally turn right to correct right. But once I hit the VOR and crossed over it from the VOR to the circling minimums, it was reversed course tracking on the 052
Yeah,
radial.
you're overcomplicating the heck out of it.
I know.
So
Yeah,
let's undercomplicate it because it's been 2 hours and I really need to eat some lunch. So let's undercomplicate this real quick.
Yeah.
Yeah. Okay. I don't care if you use one VOR or two. I don't care if you use a freaking ADF. I don't care if you can fly this approach to the ADF, have at it. Okay, you can't, but if you could, that's fine. What I care about is you making this as easy as possible. So fly the 006 outbound. When you hit your arc, start flying the arc. I don't care if you start tracking your radials based on 2 indications. If you track them based on from indications, I don't care. I always teach on from because it makes more sense to the student initially. But if you want to track on the 2s, that's fine too. It does not matter to me. But when you're on the arc, you're going to come around, okay? And when the 052 radial is selected, I don't care if you select 052 or 232. I don't care. But when it's selected, when you are intercepting, you should have a twist of the 232.
Okay.
That's just it. Like, I don't care. I don't care if you're using 2 CDIs and you do what you said, have the one always on 232. If you want to, that's fine too. I don't care. But I want you to make sure you are flying this approach on 232.
Yep. Copy that.
And then, because that is the accurate, that is accurate as to it left is left, right is right. That's the only time left is left and right is right, is if you are on a 232 heading or close to it, tracking that radial.
Yep.
Like that's just it. So when you cross the VOR, it's going to switch from a 2 to a from. And when you hit station passage, oops, I can't make this work here. When you hit station passage, start your timer, right? Or if you have DMEs, you can use 3.9, right? But
Yep.
Either start your time or just wait for the DME, and then that's it. When you hit 3.9,
2.6.
030 2000, and that's it.
That's misty. Okay, I got you. Yep. Yeah. Cool.
Let me
Yeah,
show you
no,
how
that
I
makes
do
sense.
this too. Well, here's a point too. On the mist, literally, what I do is this. I've never flown this approach before, but I can tell you this is what I would do. I would fly heading 030 and climb a 2000. While the airplane is in the turn, I'm not thinking about reverse sensing or anything. All I do is I plug in 052 at the top of my VOR. Just think about it. All I care about is joining that line, right?
Yep.
So that line is here. So I plug it in and maybe I join right here. Maybe I join on this side. I don't care,
Yeah.
but I'm going to be flying this line this way.
Cool. Yeah. Yeah, that
And
makes
then I know
sense.
I know about VIDI because I'm at 8 DME. So
Yep.
so
Cool,
does
man. Well, I
does
appreciate it.
does
Yeah,
that
no,
does
that
that
helps a lot. It's pretty much like, yeah, I know it doesn't know your heading, but if you're flying a 2 on a from flag, it's gonna be,
it's
wrong.
just confusing. Don't
Yeah.
do it. Like
Yeah.
just fly, if you're going to a station or from it doesn't matter. Like select the course you want to fly.
Yep.
Your course in your CDI should match your ground track.
Copy that.
Like your desired ground track should match your CDI course. And that's that. So, all
Yeah.
right.
Cool, man. I
You
appreciate it.
guys have, and no problem. You guys have been real troopers sticking around for 2 hours. Good grief. I never do this. I thought an hour and a half was a long time, but that's good. All right. I'm so glad that you guys all came. Thanks for asking some really good questions. I'm going to go ahead and get this uploaded right now. Tomorrow, the time is going to be at 1600 Central, which is 2100 Zulu. So a little bit later again, but we'll do that. And that one, that one has to be pretty much an hour 15 sharp, because I have a important meeting directly after that I have to drive to. So thanks for coming out. Thanks for whoever's in the chat there. Mario, I appreciate it. It's very flattering. I'm offering something to you guys too. So anybody who's listening, I need reviews and testimonials written up. So I'm offering a free one-on-one session. So I'll give you a free, just you and me, one-on-one coaching call for whatever you need, for anybody that's willing to write up testimonials and make a little video saying, hey, Toby helped me with this and that, and it was really helpful, whatever. I'm going to post it online. I want more people to come in these calls. In order to do that, I need people to realize, oh, they're getting good training over here. Let's go, get training and whatever. So that's what we're going to do. So anybody that does that, I will give a free one-on-one coaching session, and then you can do the testimonial afterwards, even if you want to. I don't care. So I'll do the session first, and then you need to write the testimonial. So that's what we're doing. All right. Well, hey, we'll see you guys tomorrow. Xander, good to see you. Adam, you as well. And Mario, Jose, Johan. How do you say that? Is it Johan or Johan? I think it's Johan. I don't know. And the rest of you, we'll see you tomorrow.
I appreciate it. Thank you for keeping it stupid simple.
See you. Thank you. Johan. Yeah.
No problem.
See you next time. Thank you. Bye-bye.
Adios, guys.